This is part 2 of 4.03, the review for heat. And the tip is mechanical devices can move heat from cooler areas to warmer areas. For example, a refrigerator moves heat from within the refrigerator to the room in which the refrigerator is located. However, these devices must use energy to move heat from a cooler area to a warmer one. So when you open the fridge door, you feel that cold air moving towards you. It's true, but think about it. Then you hear the motor kick in, and so it takes energy in order to force it to go backwards. So it's always warm to cold unless you use a mechanical device that's using more energy to force it to go the other direction. Okay, example 2. Describe molecular motion caused by heat flow. A solid piece of iron absorbs heat until it melts at 1,535 degrees Celsius. The liquid iron continues to absorb heat until it boils and becomes a gas at 2,750 degrees Celsius. Describe how the motions of the iron atoms change as the iron absorbs heat. So go ahead and hit pause, write it down, and the solution is recall relevant information. At any temperature above absolute zero, the atoms in matter are moving. In a solid, the atoms can only vibrate in place. In liquid, they can slide past one another. In a gas, they are free to move in any direction. When matter absorbs heat, its atoms move more quickly. And then solve. As the solid iron absorbs heat, the iron atoms begin to vibrate more quickly. Eventually, they have absorbed enough heat to break the metallic bonding holding them in place, and they begin to move past one another. When this occurs, the iron melts. As the liquid iron absorbs more heat, the iron atoms begin to move even more quickly. Eventually, they gain enough energy to escape the liquid. At that point, the iron begins to boil and it becomes a gas. Tip: the atoms or molecules in a liquid have enough energy to break the bonds that are holding them in fixed position, but not enough energy to break completely free of the electrostatic attractions between them. So positive, negative is an example of electrostatic. Therefore, they are free to move around, but only within a certain area. That is why a liquid has a fixed volume, but not a fixed shape. So yeah, they can move around, but they still have to be near each other. It's not like a gas that can spread out into the whole room. All right, problem set. Number 1. A student places a sphere of plastic with a temperature of negative 15 degrees Celsius into a flask of oil with a temperature of 60 degrees Celsius. Describe the heat transfer that will occur, and describe what will happen to the plastic and oil molecules as a result. Go ahead and hit pause, write down your answer. All right, and then question 2, describe how the motions of the molecules in the liquid water change as the water is cooled to below the freezing point. So go ahead and hit pause and get your answer for that one. And let's go back and look at our answers. So question 1, we put in a cold piece of plastic into a very warm flask of oil. So what's going to happen? The oil is warmer than the plastic, so heat will flow from the oil into the plastic. As the plastic absorbs the heat, its molecules will begin to move more quickly. Because remember, the oil molecules are moving quickly and they're going to hit the plastic molecules. So the oil molecules are going to slow down and at the same time make the plastic molecules go faster. And as the oil loses heat, its molecules will begin to move more slowly. This will continue until when? Until they have the same amount of kinetic motion or heat, and they're going to be the same temperature. So then all the molecules are going to be moving at the same speed, and again, they're going to have the same temperature. All right, I like to think of playing pool or billiards. When you picture these molecules bumping into each other, that's a good way to think about it. So question 2 again, describe the motion of the molecules in liquid water change as the water is cooled to below the freezing point. When the water is liquid, the water molecules have enough energy to slide past one another. As the water is cooled, the water molecules lose energy. When the water reaches the freezing point, the water molecules no longer have enough energy to slide past one another, and they become fixed in place by intermolecular bonds. The water becomes solid. The molecules can only vibrate in place. And if you were thinking, oh, I went even farther to what happens to when it gets negative 100, well, then the molecules are vibrating less, but remember, they are always still moving. Okay, that's it for this review, so go ahead and take the quiz. As always, check your quiz when you're done. If you don't understand after you checked it why you got one wrong, please contact me so I can go over it with you. Have a great day. Bye.